Hello everyone, myself Ajay. Today I am going to explain the concept of mean value theorems. It is a part of calculus and there are three types of mean value theorems. Exist Rolle's theorem and Lagrange mean value theorem, and then which is also called the first mean value theorem, and the third one is the Cauchy mean value theorem. But today I am going to explain what is the meaning of these mean value theorems. First of all, look about the Rolle's theorem. The conditions are, first, fx is continuous. Let us take a function fx. We can draw on a graph and which is continuous. Continuous means which has no breaks. If a function breaks, then it never be continuous on a graph. Suppose greatest integer function. If I am drawing the graph of the greatest integer function, so it breaks at every integral values. So this is not the continuous example of a continuous function. And take out this function like fx equal to sin x, cos x, or trigonometric function, polynomial function, quadratic and for example quadratic equation. All are the continuous functions. This shows that there is no breaks in the graph. Similar way, f dash x exists or derivable means that it has no sharp end. Sharp end means if I am drawing a function and I will not get a sharp end, see this one, pointed edge is called a sharp end. This one I will not get, so that where I cannot draw a tangent, and f dash x means tan x, that is the tangent function. So if under Rolle's theorem, the function should be, they have no sharp end, and so that's why I can draw the tangents. So if a function is continuous and then it is derivable, that is have no sharp end and has no break, then and also f equal to fb, that is the endpoints are equal, then I can find a c, at least c. In Rolle's theorem I can find a c, at least c in AB, so that f dash c vanishes. Vanishes means the tangent, at least one point in this function I can find, so that the tangent is always parallel to the x-axis. Tangent is parallel to the x-axis. So in short I can tell that Rolle's theorem deals the function where the function is continuous and it is derivable. Derivable means no breaks and no sharp ends, so that it is called derivable, and endpoints are equal, and continuous also, it is also bounded. Bounded means the function always is under restrictions. Then I can find a tangent which is, at least one tangent which is parallel to x-axis. So this is called Rolle's theorem. How to apply? Let us take an example of fx equal to modulus function, fx equal to mod x, for in the interval -1 and 1. So if I am drawing the graph of the modulus function, then what you will get for y equal to -x, and this is for y equal to +x. But it has now c, it is continuous. This function is continuous, yes, but this function is not derivable. It's not derivable. Why? Because it has the sharp end. See this one. This is the sharp end where I can't draw a tangent. Here I can draw the tangent. So the function is not derivable. It is not derivable at x equal to 0. So it's not satisfying Rolle's theorem. Take another example. So modulus function is not satisfying verifying the Rolle's theorem. Let us take another example, fx equal to cos x, the trigonometric function, and we already know if we will draw in the interval 0, 3 pi by 2. So cos 0 1 and this one pi cos pi minus 1. This is pi by 2 and cos pi minus 1, and then again cos 3 pi by 2. Every interval of pi by 2, odd number of pi by 2 will get a 0. So here 3 pi by 2 and this is minus 1. So now let us verify the conditions of Rolle theorem one by one. Fx is continuous. Yes, fx equal to cos x is continuous in this interval 0 and 5, 3 pi by 2, and it has no breaks, and so on. It may be continuous, but we are taking in this way only. This time we are taking only 0 to 3 pi by 2. The interval is 0 to 5, so in this condition it is continuous. Then f dash x exists. Here now there is no sharp end here. You can see it is a continuous flow of line. It is a curved line, so it has no sharp end. So that's why it is exist and it is derivable. There is no sharp end. Now f equal to fb. F equal to fb shows that so now we will check the third condition, f equal to fb. Now we have taken from 0, so that is called a, and 3 pi by 2 is called b. So if I am taking a equal to 0, then f0 equal to cos 0, and we are getting 1, but b equal to 3 pi by 2 is not matching, it is 0. So we have to increase the interval to 1, so that both will be the same value, give the same value, that is 1. So that's why the interval is not 3 pi by 2, it is 2 pi. It's 2 pi, yes. So both will be giving the same value. So we can't take the interval here 0 to 3 pi by 2 as the mismatching of f equal to fb. That's why we have taken it as 0 to 2 pi. Now, so the three conditions satisfied for Rolle's theorem. Now also we can find that then for at least c belongs to ab, f dash c equal to 0. So here we are getting f dash equal to 0 where the tangent is parallel to x axis. Then how to prove this that f dash equal to 0? See here. F dash x equal to minus sin x. So f dash c equal to 0. So minus sin c equal to 0, and this can happen only when sin is n pi is 0. So x equal to n pi plus minus n pi. So here it is we taken minus, so it is negative n pi. So minus pi, the only condition. So x here x equal to minus n pi, see this one, this is the pi. So automatically we are getting a tangent, at least one tangent which is parallel to x. This verify the Rolle theorem. Now come to Lagrange's mean value theorem. The same condition, fx continuous in the interval a comma b. We always take a closed interval because we restrict the function that is called bounded into some limit that is in between a and b. Now f dash x exists. Already I told you that there will be no sharp end, so that we cannot draw a tangent here. Now next, so the third condition says that f dash c equal to fb minus fa by b minus a. So there will for any point c in between a and b, we will find that the tangent f dash c, so the tangent is equal to fb by fb minus fa by b minus a. That is, the tangent is parallel to the chord. In the Rolle's theorem, we found that tangent is parallel to x-axis, but here we found the tangent is parallel to the chord. This shows that the function, if f dash c it will be positive, then it is an increasing function, and if f dash c is negative, it is an decreasing function. How? You can see this by drawing this line and by way of this one. See, the curve is going down. So this shows the according to Lagrange-Mills theorem, Lagrange shows that the function can be increased or decreased according as f dash c equal to b minus fa by b minus a. And this shows that tangent is parallel to every time to the chord of the curve. So tangent is parallel to the chord. This shows that both are the same slope. In broader meaning, we can say that instantaneous velocity is equal to the average velocity of any function.